Okay, how's everybody doing today? Good, good, good. My goal today, I'm hoping that we're going to go ahead and finish up the systems and the quadratics packet that we've been currently working on, and that we begin the currency conversion. We'll kind of see how that plays out, but we'll go ahead and do that the next couple of days. And I would really like to start the simple and compound interest before the end of the week. Do you guys remember those problems? You're going to invest $5,000 compounded biannually for 2 years, those kind. Okay, so again, another little review section. But the big items coming up next week. What's happening on Thursday the 24th? Okay, you've got your exam. So right now I'm putting it together. I may have to tweak it a little bit with the simple and the compound interest. That may or may not appear on the test because it depends on if we're able to sufficiently finish it before we take the test. But definitely geometric sequences and series will be on there. The currency conversion that we're going to start, systems, quadratics, the factoring, just being able to identify some characteristics. We're going to go ahead and talk about those and help you remember today. But that's coming up in a little over a week. Any questions on the test? All right. And I also have that packet that I was passing around yesterday for you folks to sign up for particular times where we could talk one-on-one about the IA. I know some people were absent yesterday, so I'll get that out near the end. And is there anybody who was here yesterday who has not signed it yet, or who has not thought of a time? Okay, good, good, good. Well, let's go ahead and continue. I think we just finished up letter D by the time we left. What was the strategy that I really liked when we're factoring a trinomial? There we go. My father drives a red Mercedes convertible. It's just like, please excuse my dear Aunt Sally. The first letter of every word is a step in the process. Okay. Do you want me to go ahead and write these out or just get right into a problem? Eli, just right to a problem? Yeah. Does anybody want me to go ahead and write those out? Okay, then let's do it. We'll kind of just talk about it as we go through. So I wanted to go ahead and do E and G. So E, 3x squared plus 5x plus 2. Okay, so my father drives a red Mercedes convertible. What does the first M stand for? Multiply. Specifically, what am I going to multiply, Emily? There you go. The leading coefficient by your constant. Okay, so that's going to give me 6. So I multiplied. Now the next step, this is the most crucial in the entire process. If you can guarantee you've got the two numbers that satisfy our conditions, the rest of this is going to go real easy. You've got it factored. Okay. So what two factors will multiply to give me 6, but also add to give me 5? 2 and 3. Okay. All right. So we multiplied. We factored. Now drives. What's that D stand for? Divide. So what do we divide by? Okay, we always divide by the leading coefficient. So I'm going to go ahead and divide each of these by 3. Okay, so my father drives. We multiplied. We factored. We divided. What's the R in red stand for? Reduce. We simplify. Now 2/3 isn't going to reduce, and we know 3 divided by 3 is what? It is 1. The only trick to this strategy is that if it's something like this, you want to leave it as a fraction, because I'm going to need both numerator and denominator in order to create my group factors. Okay. And then now what do I do with those? What's the next M stand for? Mercedes. Oh, we've already multiplied. Now we move them. There we go. Now we're using X. Okay, so I'm going to go ahead and get my groups ready. Now, would this fraction give me 2x plus 3 or 3x plus 2? 3x plus 2. The denominator is always the coefficient of your variable. You start at the bottom and work your way up. So this one here would just be the 1x plus 1. And typically the last step, the C, a lot of people don't really worry about this, but it stands for what? Does anybody remember? Check. Okay, you could check your work. You could multiply your expression back together and see if you end up with the original problem. Does anybody want to do that? Anybody want to run through FOIL? No? Sure. Oh, I was about to be able to use my joke if no one said yes. I could say FOILed again. Well, come on. That's a good joke. Okay. Anyways, okay, so I brought up the acronym FOIL, F-O-I-L. What's that stand for? Oh, never heard of it said that way. I've never heard of front. That would work. I've always heard of it as first outside, inside, last. Well, hey, if it works for you, there you go. So what it means, it's just a set of instructions that tells you how to multiply binomials together. So if I were to have 3x plus 2, let me give myself a little room here, times the x plus 1, okay. We multiply the first term in each group. So that's going to give me what? 3x squared. Now the outside, okay, means the furthest left and right. So 3x times 1 is going to give me a 3x. Okay. And then the inside, if those are my outside, then the other two have to be my inside. So that would be 2x, and then the last term in each group. 2 times 1 will give me the plus 2. So there's my FOIL, FOIL. And then you'll notice if we go ahead and combine my like terms, we do get the 5x in the middle. 3x squared plus 5x plus 2. Okay. And like I said, this is just the method I prefer if I'm going to factor a trinomial. If you have a method that works for you, please continue to use it. Okay. All right. Now let's take a look at the next one. I wanted to do G. There we go. So this one is 16r squared minus 169. Now I'm not going to use the method that we just talked about. And why is that? Yeah, it's just a binomial, so you wouldn't be applying this to what you have. I mean, technically you could because the linear term would come to give you 0, but it's actually a lot more work than you need. Now, I forgot to bring it up on the previous one because it didn't have one, but what's the first step if you're going to factor anything? Always look for a greatest common factor. So in G, 16r squared minus 169, is there a GCF? Is there anything that divides both 16 and 169? Besides 1. Okay. All right, so no. All right, so you said difference of squares. In fact, when you're going to factor binomials, there are 3 types that we really take a look at. The difference of squares, the difference of, starts with a C, cubes, and the, what of cubes? The sum of cubes. Okay. Now, that wasn't part of this resource, but I can go ahead and give you those if you want me to. But let's go back to G. We'll finish that up, and then if you decide want me to do that, I will. So 16r squared minus 169. Does anybody remember, what do we call the groups that you get when you factor a difference of squares? Well, they are binomials, but they form a specific type. We call them, starts with a C? Conjugates, okay. They're of the form A plus B, A minus B. The first terms are the same, while the second terms are opposites. Basically, 1 plus 1 minus. Those are conjugates. Okay, so if I recognize it as a difference of squares, I'm going to put 1 plus 1 minus. So what's the square root of a 16r squared? 4r. And the square root of 169. Okay, there you go. So it would just be 4r plus 13, 4r minus 13. Okay, there we go. Questions? Okay. Did you guys want me to go ahead and give you the formulas? I've actually never seen them on a paper exam, but did you just want them because you're super interested in math? Okay. Does anybody remember actually what the factored versions are? Like a cubed minus b cubed. What kind of polynomials will you multiply when you break them apart? A binomial and a trinomial. Okay. And every time I'm going to go ahead and factor a difference of cubes or a sum of cubes, I'm going to use SOAP. Was anybody ever taught that? Okay. Okay. So what does SOAP stand for? Does anybody remember? It's been a while. Say again, Cindy. Same, opposite, and then what's the AP? There you go. So same, opposite, and then always, and I'll just go ahead and put positive there. Okay. That's referring to your signs. So here, if you're starting with a difference, you want to start with the same sign, the opposite sign, and then that one's always positive. Does anybody remember the pattern using A and B? Like the first binomial should be straight away. It's just A minus B times A squared. Okay, is it 2AB or just AB? Okay, and then B squared. Okay. And then what's the difference between that and the sum of cubes? Well, they're okay. It's not always positive. So let's see, A cubed plus B cubed. Okay, so it's the same sign, opposite, always positive. Okay, but it would just be the same variable set. You know, you got the A, B, A squared, 2AB, and then B squared. Okay. You guys remember that? Okay. Okay, cool. All right, let's see. Solving equations by factoring. Which ones did I want to do here? I wanted to do B and F. B and F. Okay. And you got yourself an example right here. But once you factor it, setting each of those group factors equal to 0, what do we call that? Remember, that's zero product property. Okay, so you're just solving a different type of equation. You're wanting to find any value or values that makes the equation true. Now, this one, 3x squared minus 27 is equal to 0. You'll notice there is a GCF. Okay, and then if I were to pull out the GCF, it's then a what? It's a difference of squares. So I can absolutely solve the problem by doing that, but you know, I don't know if I would go with factoring so much. If it's just an equation where you have a single variable, I might just isolate the variable and go from there. Okay, but I'll go ahead and solve it however you want. Factoring or just isolating the variable. Graceland, what do you like? Factoring? Okay, so let's factor it. What is the GCF I referred to? 3. Okay, so I'm going to pull out the 3. That's going to leave me x squared minus 9 is equal to 0. Now, we're trying to solve for x, so actually pulling this out, I really could just go ahead and now divide through by the 3, so I've got x squared minus 9 is equal to 0. I can just kind of get rid of him. He's not necessary. Okay. So we said that was a difference of squares. What are the conjugates? X plus 3, x minus 3 is equal to 0. And then the zero product property would be just to set each one equal to 0. So either x plus 3 equals 0, in which case x would equal negative 3, or x minus 3 is equal to 0, in which case x would equal 3. You could probably even just combine them and say your answer is x equals plus or minus 3. In fact, did anybody want to see me just solve it using isolation? Yes? Okay. So let's say I wanted to solve the same problem. 3x squared minus 27 equals 0. How would I get 3x squared by itself? Okay, so add 27. Okay, so 3x squared is equal to 27. We divide by 3. Remember, you're always using the opposite operation. So x squared is equal to 9. Yeah, and this is the only thing you have to remember when you're solving an algebraic equation and you take an even root, square root, fourth root, sixth root, etc., you want to go ahead and put the plus minus in front of it. So x is equal to plus or minus 3. So see, we're still going to get the same thing. Okay. We definitely got to the root of that problem. Really? Not one of my better ones, I guess? No. I was really quiet when I said that. Okay. All right, questions? All right, let's take a look at F. Okay, 11x equals 2 plus 15x squared. Okay, so I'm going to go ahead and rewrite this. I like to have everything on one side, especially if you're going to factor. You're definitely going to want to do that. So I'm going to go ahead and say that 0 is equal to 15x squared minus 11x plus 2. See, all I did was subtract the 11x over. Okay. Now, it also depends if you're going to use the quadratic formula, and I'm just going to go ahead and bring this up because we're talking about quadratics, you would want to set the equation equal to 0 as well if you were going to solve by completing the square. Does that sound familiar? Okay, some people kind of remember completing the square. That's a great method. In fact, of all of them, though, I probably am going to go with the quadratic formula because I think it's the fastest, but okay. You guys want to try this one on your own, factoring it? Okay. All right, so let me give you a little bit of time. See if you can break that apart, find out what the value or values of x will be. Oh, okay, cool. Yeah. Okay, so you may not have had time to break it up completely, and that's okay. Let's just let me catch up to you. So let's say I want to go ahead and do this the way that I like, the my father method. So what do I do first? Okay, multiply what two numbers? Not high pudding. Okay, but what two numbers will I multiply? 15 and 2, always the leading coefficient by the constant. Now that gives me 30. Now this one here, we've got a positive product, but a negative linear term. So what's that telling me about my two factors? Okay, they're both negative? Okay, so both negative. Okay. So let's see here. What two numbers will multiply to give me 30, but then add to give me negative 11? 5 and 6. There we go. Okay, and be careful, signs are very, very important with this. If you were just to choose 5 and 6, I mean, 5 times 6 is still 30, right? But why would those not be correct? It would add to 11, not negative 11. There you go. Okay, now what? Okay, divide by 15. Always divide by the leading coefficient. So negative 5/15, negative 1/3, negative 6/15, negative 2/5. Okay, so we've multiplied, factored, divided, reduced, and now I'm going to move the numbers. And remember, this whole time it's still equal to 0 because we're solving the equation. So what would this be? Would that be negative x plus 3 or 3x minus 1? 3x minus 1. We always start in the denominator. 3x minus 1. This would be 5x minus 2. Okay, and then we just take those groups, set them equal to 0. So if 3x minus 1 is equal to 0, what I like to do, if it's a two-step equation, I encourage my students to go ahead and do that mentally. But does anybody want to see me actually just write everything out? You'd want to see me write everything out? Okay. So the first thing I would do is what? Okay, move the 1 over, so the opposite would be to add it. Those cancel. So 3x is equal to 1. Okay, divide through. So we have my first solution. X equals 1/3. Okay. And then we'll do the same thing for the other one. 5x minus 2 is equal to 0. So I'll start by adding the 2. Those cancel. 5x is equal to 2. Divide through by 5. So the second solution would be 2/5. Okay. we go. Questions. Hey. Oh no, they would both work. So what this tells me graphically is that I have two locations where the graph is touching the x-axis. And sometimes you'll only get one, and sometimes you won't get any at all. And do you guys remember what was called the discriminant? Does that sound familiar? What was the quadratic formula? X equals what? There you go. That's the quadratic formula. So typically, unless it's something that can be factored, pretty quick and easily with no effort, I'm probably going to go ahead and run with the quadratic formula because it's just substitution. You plug in A, B, and C, boom, you're going to be able to get your roots pretty quick. But the discriminant was the radicand of the expression, b squared minus 4ac. Remember, if you calculated that, if you got a positive number, then that told you there was what? How many real roots? Okay, there would be 2. If it was 0, then that means there's 1. And if it was a negative number, that means no real, but that means it's going to be imaginary. Okay, and you can see that graphically if you were to take a look at it. Okay, let's try that again. All right, because a quadratic, no matter how it opens up or down, you could have a parabola crossing 2 locations. You could have a parabola only crossing 1. That means the vertex is in contact with the x-axis, or it's very possible that the parabola might not touch the axis at all, and that's where you're going to get the imaginary. Okay. How much is this kind of just starting to just flood back as we go through it? Good old days, right? Okay. Questions? Okay, well, I think we just have the one little section left. Okay. All right. Solve the quadratic equation by using the GDC. Okay, so this right here, we're going to go ahead and use the graphing calculator. Round all answers to 3 significant digits. If no solution exists, then we want to go ahead and state so. And it kind of walks you through how to do it there. I'm going to go ahead and do it for you in just a second. But just a couple things. If you're talking about standard form, ax squared plus bx plus c is equal to 0. That's the standard form of a quadratic. And you always want to be careful what it is you're talking about, because when you say standard form for linear, it's something completely different, but it has the same name, right? So we call this the quadratic term, the x squared. We call bx starts with L, the linear term, and then c is your constant term. And you're always going to see this with one restriction, the fact that a cannot equal 0. Because what happens if a is equal to 0? Yeah, because see, this part just disappears, bx plus c. Well, there's your mx plus b. Okay, we're just using different variables here. Okay, so a couple things. How can you always tell the direction that the parabola is going to open? Yeah, the sign of the quadratic coefficient. If it's positive, it's up. Negative, it's going to be down. Okay, what's its y-intercept? It's always c. So the y-intercept is always going to be located at 0, c. Okay. Now, I don't think we've ever had the opportunity to bring this up here. Does anybody remember? Let's say I have this in standard form, and I'm not interested in completing the square to rewrite it in vertex form, but let's say I want to know the vertex of this parabola. Does anybody remember that little expression, the ratio that will give me x? Anybody? Okay. Does this look familiar? The opposite of b divided by 2a. Okay. In fact, if your parabola opens up or down, that's my blank of blank. Axis of symmetry. Yes, very good. Okay. Now, where the axis of symmetry and the parabola intersect, well, that's the vertex. So if you're thinking in terms of, you've probably heard minimum and maximum before. That's the y value associated with the vertex, and it has a lot of applications. But if I want to know the maximum or minimum, depending on if it opens up or down, I take this value of x and I plug it back into the function. Okay. I'm trying just to cover a lot of bases here and make sure you remember a lot of the characteristics of parabolas. Now, we're going to be seeing them again, in a few weeks, but does that look familiar to anybody? Do you remember using that? Okay. Does anybody want me to go ahead and apply that to an example we already talked about? No? You want me to do it?
Yes.
Okay, let's do it. Okay. So let's see here. How about this one right here? Let's just go ahead and use A. So I'm going to rewrite this. X squared plus 2x minus 8 is equal to 0. Now this one wants me to go ahead and factor it. I'm going to go ahead and find out quite a bit of information about it. Okay. In fact, why don't we go ahead and, actually find the roots where it crosses the x-axis so I can graph it and we can actually see these characteristics. All right, so let me go ahead and get this out of the way here. Okay, so this one, we probably don't need to run through that process that I've been talking to you about. What two numbers can multiply to give me a negative 8, but then also add to give me a positive 2? Okay, so it's going to be 4 minus 2. Would you guys agree? Could it be x minus 4 and x plus 2? That's still negative 8 when I multiply. Then it would give me negative 2. Again, always pay attention to your signs. So if I were to set these equal to 0, if x plus 4 is equal to 0, x equals negative 4. If x minus 2 is equal to 0, then x would equal 2. And there's also something really cool you can do to kind of confirm. Okay. And I don't know if your teacher, ever talked about this or had you do it. Let's see here. Okay. So let's say I want to go ahead and mark these. This guy's definitely going to open up, right? Because 1 is positive, the 1x squared. So it's crossing at negative 4 and 2. Okay. Now remember, the parabolas are always symmetrical. They have that axis of symmetry going straight down the middle of them. Okay. So we can kind of predict what's halfway between negative 4 and 2. Negative 1. So I'm willing to bet that my axis of symmetry is going to look just like that. It's got to occur at negative 1. Now remember, what was that little expression that gave me the x value of the vertex? X equals the opposite of b divided by 2a. And remember, you get a, b, and c from the equation. A is the quadratic coefficient, b is the linear, and c is your constant. Okay. In fact, you want to make sure that everything, again, is on the same side, because if they're on different sides, then you're not going to have the right sign. Okay, so if b is 2, well, the opposite would be negative 2, divided by 2 times what's a? 1. And you'll notice, look what happens. Negative 2 divided by 2, there's your negative 1. Okay. So the vertex has to be at negative 1 something. Okay. How would I figure out what the y value is? Remember, what did I say with the expression? Once you find that value of x, what's this f of opposite b over 2a mean?
So set that value equal to x and then solve the equation.
Say it one more time, Eli.
So would you set that value for x in the equation?
There you go. You just substitute it in. Okay. Because this value here is x. I'm looking for the corresponding y value. So I'm just going to substitute. X squared would be what? Okay. Well, I'll just go ahead and plug in. Why not? Negative 1 squared plus 2x, 2 times negative 1, and then we have minus 8. All right, so let's see here. That was 1 minus 2 minus 8. So it should be what? Negative 9. So the vertex should be at negative 1, negative 9. Okay. Is everybody okay how I got the negative 9? All right. What's the y-intercept? Remember, it's negative 8. So this is not going to be to scale. So let's say the negative 8 is right here. And then we'll go ahead and say negative 9 is right here. Okay. So, yeah, this is not going to be pretty, but there you go. Because it's not to scale, but there you go. You guys remember a lot of this? Okay. Okay. Well, let's say that your expression isn't factorable, or the values, the roots aren't going to come out very nicely, and that is where we're probably going to want to use technology. Okay, which ones do I want to do here? I want to do A, C, and F. A, C, and F. Okay, so we want to go ahead and round all answers to 3 sig figs. We want to find the roots. Okay, so let's go ahead and plug this in. X squared minus X minus 4. So I'm going to come on over here to my calculator. Now we want to make sure to be on our graph screen. X squared minus X minus 4. Okay, so here we go. And if it helps, we can go ahead and move this guy over to the side. But what I want to do is go ahead and find the value of these right here. So I'm going to go ahead and hit menu. Does anybody know where I go? Okay, 6. Now you could trace it, but I think analyze graph is going to be the better way to go. Now finding the root, that's the same as finding the 0. Okay. And I don't know, have we ever talked about one of these in here? The intersection using this? I can't remember if we have or not. We have, okay. So remember the lower bound, whatever value you're looking for, let's say we want the positive root, just go ahead and put this vertical line to the left of where you believe the point is, what you're looking for. I'm going to push enter. See, it's going to mark that location. Now when it says upper bound, if I slide that over to the right, as soon as it hits that point, it's going to go ahead and pop up what I'm looking for, 2.56. So that's going to be one of my roots. Okay. And then now I'd want to go ahead and do the same thing for the other one. Menu, remember we went to analyze, 0. So now I'm looking for this one right here, so I'm going to put it on the left. And remember, I mean, you could even go pretty far left if you want. Okay. And then just slide it over. So that one is a negative 1.56. What's that, man? Oh, did you mean, the quadratic formula? I thought you were talking about plugging it in. I think that might work as well. Let me try this. I know that you can use this, but I know that occasionally it won't give you both roots. Let me try this. How do we bring up numerical solve? Menu. Okay, algebra, and then numerical solve. So let's see. We had x squared minus x minus 4 equals 0. Okay. Then at the end of numerical solve, remember, you always have to put a comma and then identify what variable it is you're solving for. So I'm going to push enter. Okay. And see, it only gave me the 1.
Well, so what you can also do is you can find just find the polynomial roots.
Mm-hmm.
So if you go to menu.
Okay. So from here, go to menu.
Yes, you get menu and then algebra. Polynomial tools. And then just find roots of the polynomial.
Oh, find the roots of the polynomial. Okay. All right. Okay, so that's, what was it, x squared minus 4x?
Minus 1 and then negative 1.
Okay. Negative 1 and then negative 4. Nice. Okay, very cool. There you go. Was that the, you did a little while ago? Okay, cool. All right. So did everybody see how we got into each of those? Okay. To get into what Eli was just showing us, he went to menu, he went to algebra again, polynomial tools, find the roots. Okay. Okay, and the degree is 2. That's my largest power. Just type it in. There you go. Okay. And remember, this is what's really going to make the difference on that paper exam, is being able to work the calculator correctly. Is everybody okay with that? Okay. Well, good, 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 good. What other ones did I say I wanted to work on there? I said I also wanted to do C and F. Okay. So let's try C, and how would you like to do that? You just want to graph it? Did you want to go ahead and find the roots as Eli had said, or what would you guys like? Zoe, what do you think? Let's graph it. So x squared minus 3x plus 7. Okay. So I'm going to go ahead, document B. Okay. So x squared, it was minus 3x minus 7. Is that right? Okay. So I'll say enter. Oh, was it plus 7? Okay, I'm sorry. Let me go back up here then. Let me change that. There we go. And actually, we brought this up just a moment ago. Uh, what are my real roots if it does not cross the x-axis? There are none. They would be imaginary if we wanted to find them. Okay, there you go. Okay, very good. And then on this last one right here, we got f x squared plus 9, and then we have equals 8x. Let's go with Eli's again. X squared plus 9 equals 8x. So I'm going to go back over here, back to my calculate. So menu, algebra, polynomial tools, find the roots. Okay. Let's see, then it was 1, -8, and then positive 9, right? Okay. Because you got to make sure they're in order, they are all on the same side. Okay, and then push enter. Boom, there are your roots. 1.35, 6.65. Perfect.
And that method will actually, it'll give you the imaginary roots too.
Oh yeah, that little tab, you click real to imaginary. So we'll do it in terms of I?
Yeah, so I did it C, because I
Uh-huh.
was really confused, and it gave me 3 over 2 minus 2.18 I, comma 3 over 2 plus 2.18 I.
Nice. It probably went ahead and simplified the radical, but then just separated the -1 from it. Okay. Because you guys remember, what is the definition of I? Yeah, square root of -1. Good. See, that's why you guys are excellent pupils. Because I is imaginary. Really? That was a good one. Okay. Okay, I'll go ahead and give you that joke. It was a little cornea, but really? That was better. Okay. Better. Okay, well, here's how we're going to go ahead and end today. You're probably wondering why we were skipping through. You probably already figured it out. This packet here is both your notes and homework. So all of the problems that we did not work together, that's your assignment. So you notice how through the entire packet I was just skipping and choosing particular problems. So all the ones that we did not work together, that's your assignment. So let's say that's going to be due Thursday. So I'll give you 2 days, no rush on that. Unless you want to go ahead and get it done tomorrow. I would say 2 days. Okay, so let's go with Thursday. Okay, so Thursday the 17th, we'll go ahead and turn this in. Here's how we're going to finish up today. I do want to go ahead and start currency conversion, but we need to know what the conversions are. Okay. Now, granted, these exchange rates are a little over a year old, so absolutely they have changed by this point, but it's not really what the value is. Whatever the true value is, as long as you know how to change it, you're going to be fine. So like on the paper exams, you're always going to be provided with whatever the exchange rate is in order to work the problem. Okay, so I'm just going to go ahead and give you the rest of the time to go ahead and copy those numbers. Okay. Would it be better if the lights were on or off? On? Okay. Okay, in fact, this was current as of December 2017. So like I said, it's just a little over a year. Yes, ma'am. Yeah, that is a 7.4. So that's 0.74673 for the British pound. Okay. So like, for example, this first column here, this is, if you're looking at the very first row, Australian dollar. So 1 US dollar is worth about 1.33 Australian dollars. Okay. So you can be able to tell how the conversion works. So in this case here, the one Australian dollar is worth about maybe 75 cents American. Okay. All right. I would probably go ahead and have the whole thing down just because the more decimals you take, I mean, this is what I pulled directly off the internet search in 2017 when I went and looked for it. So I mean, I would probably say, it's not bad because your proportions are going to be pretty small, so pretty easy to do that. I mean, if you want to, you can. Your answers will just be slightly different. And in fact, it looks like we're not going to be able to get to it today. Who needed the key for yesterday's homework? Why don't you folks just go ahead and give me the assignment, and I'll get that back to you tomorrow. That way we're sure that it's gotten turned in. Okay. Japanese yen. Okay. Uh, that's 113.45. Okay. Thank you, ma'am. Thank you. All right. And it looks like we're getting down to our last couple of minutes. So if you're not able to get this entirely copied, I won't be putting it up again. No, I'm kidding, right? Some people looked at me like, what the hell are you talking about? Okay. Yeah, if we don't get it copied today, we'll put it up tomorrow. I'm not a monster. All right.
Did you watch the Spider-Man trailer?
I did. I actually saw it. Uh, One of my students, does anybody know Caleb Hill?
Caleb Hale.
He and I talk about comic books and movies and such a lot. And he walked in. He was like, the trailer dropped 12 minutes ago. And I was like, holy crap, we got to make time in class to watch it. So I actually moved some things around so that we could take the last 5 minutes to watch the trailer. I would have done that in here, but somebody had said, I want to get these copied before we leave. So I was like, okay. Well, I've got 206. Would you like me to go ahead if I'm going to put it up tomorrow and we just watch the trailer?
Yes.
Okay.